Well, hello and welcome everyone. I'm delighted to moderate this outstanding panel to discuss what is an important enabler to training simulation systems, the graphics processing unit, GPU. Our topic today is how GPUs can revolutionize training and simulation, Nvidia's new Ampere. To put it another way, how can the GPU help accelerate change? I'm Jim Skurka, an independent consultant these days with past experience in both the government and private industry around military training and simulation systems. And so I'd like to now introduce the panel to you. First from Nvidia, who, as you all know, is the world leader in GPUs as well as artificial intelligence, many other areas. Doug Traill. Doug?
Thanks, Jim. I'm looking forward to this. So I'm the Director of Solution Architecture and Engineering at Nvidia for professional visualization. So that covers everything from our rendering products to our virtual reality, augmented reality, and our virtualization products as well.
Okay, thank you, Doug. Tim Woodward.
Everyone, Tim, I'm also a solution architect. I'm on Doug's team, in fact, and my background is in training and simulation. I spent 20 years developing visual systems for flight sims and the like before joining Nvidia about 4 years ago. So my focus now is on helping this industry get the most out of the GPU.
Okay, thank you, Tim. And from RAVE Computer, those of you who don't know RAVE Computer, they're a small business computer integrator with over 30 years experience in both military and non-military markets. Karl Rosenberger. Karl?
Everyone, I'm Chief Technologist at RAVE Computer, and I've been there 28 years. I currently lead the product development team developing innovative purpose-built solutions.
Thank you, Karl. And Matt Moy. Matt?
Hello, everyone. Thanks for joining us today. My name is Matt Moy. I'm a systems engineer. I've been working on the RAVE product development team for 10 years now with a focus on GPU-based systems. And basically what we do is we work to leverage the latest developments in technology and in GPUs to deliver solutions that are tailored specifically to our customers' needs in a lot of cases in this industry specifically.
Thank you, Matt. Okay, to begin the discussion topics, what I'm going to do is I'll be asking questions to the panel. Now, some of these questions are based on your comments that you made during the registration process about what you'd like us to cover in this webinar. You can also ask questions via chat. We're going to do our best in the limited time to answer them. If your question's not answered, or if you have some follow-up questions, or if you want to talk privately, please go to the RAVE virtual exhibit booth at ITSEC. Both RAVE and Nvidia will be available through that booth. And as an alternative, you can always go to RAVE directly and they'll get you to the right person. So I'm going to focus the panel questions on military training simulation needs, but there is a much larger market demand for GPUs, the entertainment industry, industrial development, and especially more and more immersive and multiplayer gaming. But the military is depending on leveraging that commercial market, both to take advantage of rapid technology performance as well as cost advantages. And both Nvidia and RAVE do just that and have done for many years. They leverage commercial products that best suit the military users and the system integration company's specific needs. So I think they're great companies to be representing, great panel members on this panel to talk about this question. So let me just take a few minutes to set some framework. So as you all know, training simulation continues to grow across the military services. And it ranges from maintenance to operator to crew to staff. And in fact, more and more simulators are linked to allow large-scale collective training. But there's a training revolution taking place. And ITSEC, the people at ITSEC talked about it a whole lot this week. It aims to satisfy new military needs by leveraging technology progress. And a few of those military needs go well beyond current commercial needs. For example, training at the point of need. So now we're talking about training at places where there might be very minimal infrastructure. Or on-demand training. Now you've got to pull a lot of data, maybe either from storage or from the cloud. More and more realistic simulations for not just training, but for mission rehearsal. geographically dispersed but yet securely connected training system across the services, but not only the services, partners and allies. And finally, connected trainees on live training engagement. So there's a whole lot of things that need to be adapted from that commercial marketplace to the military needs. So let's discuss now how this GPU enabler and its associated hardware stack, and let's not forget about the hardware stack, you know, the form factor, the cooling, the power supply, the CPU that goes into helping satisfy these current and future military needs. So on to first question. So what are 2 or 3 performance features in the new NVIDIA Ampere architecture that can directly benefit military training and simulation products? And will Ampere GPUs replace the current product line? And let me send that to NVIDIA. And Tim, could you take that on?
Yeah, sure. So Ampere is the latest generation of NVIDIA's GPUs, and we continue to make advancements in a couple of key areas that I think will have an impact on the training and simulation world. If you've been living under a rock, we've been focusing a lot on ray tracing lately. So ray tracing is it's been around a long time, but Ampere brings significant acceleration to ray tracing, which enables much more realistic images to be produced. You know, to the extent that training and sim applications utilize ray tracing, they will see significant advancements in performance, significant improvement in performance moving to Ampere. The second area is related to that is artificial intelligence. So a part of our chip is dedicated to accelerating artificial intelligence. They're called Tensor Cores. And so similar to ray tracing, to the extent that applications can utilize deep learning, machine learning algorithms in their workflows, we work to accelerate pretty much everything you can imagine of all the frameworks in that space with our GPUs. So Ampere ups the level of the performance when it comes to artificial intelligence. And then just straight up rendering performance with CUDA cores. So if you look at the number of CUDA cores in Ampere versus the previous gen, it's over double. So the capabilities are there. I think what we'll see a lot of is increased realism as applications begin to utilize those features.
Do you see AI being used within GPUs today, or is this something, you know, completely new with Ampere?
No, I think the reason we're talking about AI so much today is because of GPUs. It's GPUs that have enabled AI to become practical for so many use cases. And you kind of said this earlier, Jim, about being able to leverage what's happening in other industries. More and more, we're seeing this cross-section of how AI, being accelerated by the GPU, can also accelerate graphics operations. And that's where I see some of the most interesting stuff happening, being able to use things like denoising or generative adversarial networks to produce more realistic content. There's all kinds of applications where AI comes into play that can be used to increase the fidelity and performance of computer graphics, in addition to all the other traditional AI type workloads.
And just adding to what Tim said there, I mean, that's a very hard question being asked, what's the 3 performance features? Like being asked, you know, which one's your favorite child? It's often not fair. But, you know, as Tim says, this is our 3rd generation of Tensor Core on the GPU. And a Tensor Core is just a fancy way of doing a complex mathematical operation in just one clock cycle. And that's what the Tensor Core is. And that matrix multiplication comes from all of these AI frameworks. And this being our 3rd generation, AI is kind of grown up. It used to be, we would talk to developers about AI, the researchers. Now you use AI every day. And even in our gaming technologies, things like DLSS, is using AI to sample to increase the resolution of a frame. So it's just becoming more prevalent to everyone.
So does the new Ampere product line of GPUs today replace the current product line, or are they plug compatible? What's the situation there? Let me ask Rave that. So, Karl?
In our case, we have the professional workstation integration work that we do. There's some overlap there. And then with the gaming cards, the GeForce cards, there's not really any overlap. The previous generation is gone.
Yeah. So Tim, you're shaking your head. What can you
Yeah,
add?
that kind of represents a pretty significant difference in how the consumer graphics card world works versus the professional side. So when we launch a new architecture, we'll often keep the previous generation, even the one before it, alive for quite some time. So this is where, you know, long life cycle in this space can benefit from professional GPUs, which will be around for a long time. And some of the reason for that, if you look at some of our GPUs, they get put into medical devices and other things that take a long time to certify, and they need to be supported for a long amount of time. So they're just different approaches for these different markets. You know, consumer gaming doesn't really care so much about continuity of configuration. So when a new GPU comes out, it's fine if they replace it with something totally different. Form factor is less important there. Whereas on the professional side, and Karl kind of brought this up, the systems that can support the previous gen professional GPU, it's basically a drop-in replacement with the new architecture.
Yeah. Okay.
And to Tim's point there, even within a single architecture or a single generation of consumer cards, it's not a given that those cards will maintain the same design throughout their life cycle. So one of the challenges we deal with at RAVE when supporting those cards is, you know, some specific third-party vendor GeForce cards may go end of life, and the replacement cards may have different cooling characteristics or different dimensions. So even within a single product line, like a 3080 as an example, you know, we may have to deal with many changes throughout that short product life just to maintain, you know, a consistent build. Whereas of course, you know, the Quadro just eliminates all of that.
Yeah, and I think it's just adding to that. You know, this is a big difference in Nvidia's go-to-market strategy. We love our GeForce cards. They are absolutely excellent. We design the best graphics cards for video gamers. And that's shown out in the market by the number of people who are playing video games today, partly because of the situation that we're in now, unfortunately. But, you know, we're creating these excellent products for gamers. And for that, it's a consumer market. It's consumer driven. Nvidia has approximately 30 licensees who can manufacture a GeForce card. And to Matt's point, that means that the card that you buy today will likely be a different card than you would buy, you know, in a year's time or 2 years' time from a manufacturer. And that can cause unforeseen problems. Our professional cards, we're trying to sell into a different market segment. We're a business-to-business relationship there. So we're selling through the likes of RAVE, who are certifying the entire package. So the entire computer system is certified for the GPU and is certified for that CPU, cooling, packages, memory, everything like that. So you get a consistent product at the end of the day that just works. And that's what people are looking for.
So that's a good point. So you talk about the entire product. So Karl or Matt, can you talk about what does that computer stack look like? What are those other important features of that computer stack that kind of go along with the GPU to make a successful product?
Well, we could start with the form factor. You know, you've got a certain amount of area that you need to work within to meet an application need typically. But within that, you've got to get your mechanical space for the different components. The GPU is a very large component. You've got to supply power to everything. So you need a sufficient power supply and you need a compatible power supply. The cooling system is one of the things that we do a lot of work on before we release a system to a customer to make sure we're keeping everything cool, because when you keep things cool, clocks go up, performance goes up, stays up, everyone's happy.
That brings me, that's a good point. That brings me to the next question. So, I mentioned earlier, providing these military training systems that are located at the point of need, for instance, starts to present some challenges, okay? Size for one, power consumption for another, connectivity to the edge for a third, and sometimes wirelessly. So can you talk about some of the key GPU technology trends that might address some of these particular challenges that the military brings? Tim, let me turn to you on that one first.
Yeah, sure. I mean, I think the biggest area where we've been developing technology that would address what you've described, this point of need problem, kind of falls into this category of virtualization and streaming. So, if you look at a lot of the ways we've done this in the past, if you want to have, a high fidelity experience at the edge, it means you're either tethered to a computer or you have one on your back. And so we've compromised with these kind of all-in-one headset devices, for example, if you're trying to do VR or AR, and they have limited compute capabilities on board. So what we can begin to do now, though, is offload the work from those devices and move that into the data center. And with a high speed, high bandwidth, low latency network, we can stream pixels to that device, effectively offloading the bulk of the work. And that allows you to then have that high fidelity experience at the edge without a lot of power, without a lot of weight. And so this is where virtualization and streaming come into play. And it brings a lot of advantages now, because you can consolidate all of those computing resources into one place, where before you had lots of individual separate systems that had to be managed. It's in a controlled environment now, from an IT perspective. Just tremendous advantages. And this is a great example of, again, leveraging the work that's happening for other industries into training and sim, because, VDI and virtualization has been around a long time, but there's a tremendous need there to be able to remotely access, high performance graphics.
So let's talk about virtualization a little more. So to me, one of the benefits starts to be I can support multiple thin clients from the edge wirelessly. How many thin clients, let's say headsets, can we support these days running the current GPUs and the current hardware stacks? Karl, could you take that one on?
Yeah, a couple things. For about, 6 or 7 years, we've been working with VDI at RAVE, and the problem back then was you didn't have the ability to have advanced graphics at the virtual desktop. And Nvidia's done a ton of work there. And so now we can pass through an entire GPU to a virtual desktop instance. If you look behind Matt in the picture there are 4 of them running on a single machine. They each have a thin client hooked up, and they have their own peripherals hooked up to them. You can see on the counter. That picture is actually taken at ITSEC last year, but we've been demoing that particular type of configuration with incremental improvements for the last 3 or 4 years. Is that right, Matt?
Yes.
Longer than that.
And I just switched the photo over so you could see the actual server. It's actually a very small, short depth 4U that's powering all 4 of those nodes.
So if you imagine one of our other servers that holds up to 10 GPUs, then we could do direct pass-through of each of those 10 GPUs from a single 4U system. But then you can alternatively slice the GPUs up. And I'll let Matt talk a little bit more about what we've done there.
Yeah, so if you need the rendering power or rendering capability that is on par with a very high-end single server, then that's where the pass-through is ideal. So that's what we are doing on this demo here, also just to keep things simple for demo purposes. So on the system behind me, we've got 4 RTX 6000 cards, and the server is running, in this case, ESXi with 4 virtual machines, each with their own dedicated card. I'll flip back to the other image for a moment here. And what we're doing here is there's a couple of different ways we've demoed this now. The first few times we did this at ITSEC, we had a server in the center of the booth, and then we had little thin client nodes that would basically remote into the virtual machines and give you the display output and the peripheral connectivity. And at last year's ITSEC, we did it slightly differently. And we directly connected everything to that single server. So here you've got, it's hard to see, but you've got 4 displays, 4 sets of peripherals. All of that is cabled directly into that short depth 4U server that we were showing you just a moment ago. But what Karl's referencing is basically slicing the GPUs into multiple instances. So one of the great things NVIDIA has done is created SDKs and software to support the ability to basically time slice these GPUs. So you can stretch the resources as far as you need to. Now, certainly that comes at a cost. So the more you slice the GPU, the more instances, the more virtual machines that you run off of a single card, the lower the performance capability is. But it's surprisingly efficient because there's a lot of resources on those cards that don't necessarily get fully utilized. So when you slice a GPU into 4 instances, for example, in a lot of cases, you're getting a lot more than just a quarter of that performance. So that's where you get a little more efficiency. And then on top of that, when things are virtualized, you have the ability to quickly and easily reallocate resources on an as-needed basis. So if there's a particular IG that you're running on a virtual machine that needs a little more resource than some of the others, you can allocate things differently to really dial it in and squeeze every last drop of performance out of the hardware.
Yeah. So I've heard that quite a bit, that the underutilization of the contemporary GPU, I'll call it. So NVIDIA, and guys, could you talk a little bit about that? I mean, what's going on? Are people taking advantage of everything that's there? And does Ampere even give more that people need to consider more than just rendering and virtualization? Is there more there that people need to be thinking about?
It very much depends on the application that you're running. So a large number of applications, especially in military programs and federal programs, they might have been developed for hardware generations that are 4 or 5 years or even longer than that, sort of old. So if they were designed for our Kepler generation of GPU, you don't necessarily see a massive speed up if you run that application, or you don't even need that speed up if you run that application on an Ampere card. And this is where we can take advantage of putting more applications being run in parallel on that card as we split it up between the GPUs. It's not going to work for every application. If you are looking at flight simulators and you're trying to drive a display at 360 Hertz, then I do not recommend virtualization technology to you. But if you are doing a basic flight simulator training where you're looking at instrumentation panel and you're looking at how to read the instruments as your first step as a pilot, then this technology is perfect for that type of use case. So it really depends on the application that you're trying to run. But it's a great technology. We have over 1 million licenses sold. So there's like 1 million users out there that use our vGPU technology today around the world. So it's a nice mature technology. This is not something new that we're launching here. We're just bringing it into this space.
Yeah. So I had a question of one of the audience members. It was interesting to me, and I'd like you to comment. So the question, well, actually the comment was, as we continue to work within virtual environments, it appears that the GPUs have become our limiting factor. It would be great to know what's coming down the pike. So talk about that. To what extent has the GPU become the limiting factor in virtual environments?
That's hard to say, because one of the advantages of our technology is that you can have multiple GPUs in a virtual machine. So even if you didn't want to, time slice the GPU, you can actually multiply it. So I could have 2 or 3 or 4 GPUs in a single virtual machine to give more use. So I'd be interested in talking to whoever sent in that question, as where they're seeing, where they see the GPU as being the limiting factor.
Okay.
In most cases, we run out of CPU cores before we run out of GPU cores for processing in applications.
Interesting.
So that's the kind of, and we're always looking to, understand people's use cases. We're always adding to this. So just now we have an SDK called Cloud XR, and that's designed to help you stream virtual reality applications from a virtualized environment or a remote platform environment. We a remote workstation. We see them as the same thing. So we're continually trying to push the boundary of what we can do by streaming technology.
Okay, great. Okay, appreciate that. So there's certainly an opening to. I'm not going to talk about who asked the question, but there you go. We can hook you up through the RAVE booth, or to look at your specific application. Next question. So cost is obviously key consideration in customers' GPU selection, and more, particularly in the training business. Just people looking to keep down the costs in the training business. And Nvidia offers both and you talked about it a little bit before, a consumer gaming line as well as a professional line. So could you talk about the key differences that a particular application needs to be looking at? Those differences in the commercial versus the consumer product that they need to consider in deciding which product is best for them. Tim, would you take that on?
Sure. Yeah, I think maybe one thing a lot of people may not realize about NVIDIA is that we have more software engineers than we do hardware. And so a lot of the investment that we make on the professional side is in software related features. So when you look at our Quadro GPUs and other professional GPUs, they support things like warp and blend natively on the GPU, or synchronization natively with the GPU. They have larger frame buffers, so significantly more memory. There's advanced display technologies for overriding EDID. There's just many of these features that act as effectively a superset of what's available in the consumer side.
So you could offset functions you're doing to the GPU that you may be doing elsewhere, is what you're saying.
That's exactly right. So you either have custom software that's fulfilling those functions, or in some cases specialized hardware that's required for those functions that are just natively supported inside our professional GPUs. So this really becomes about awareness, knowing what those capabilities are, and to the extent possible, leveraging those capabilities. And one of the other ones we talked about today was virtualization, right? So that's something that's exclusive to the professional side. And think about cost. Well, as you increase user density on a system, you're reducing the overall cost for each user. And being able to have a flexible system is very valuable. So a single workstation or a single server with multiple GPUs can be configured for different kinds of workloads. So maybe you get more utilization out of that system because you're using professional GPUs versus consumer, where you'd be back to a more traditional single GPU and a single node, and that limits the kinds of configurations that are possible.
Okay, and Karl, from a computer integrator standpoint, obviously I guess there could be impacts of the selection of a computer device. Suddenly it's out of production. Can you talk a little bit about how that choice affects you, commercial versus professional GPU?
Certainly.
Stack, yeah.
One of the biggest things is when you go to the professional side, we talked earlier about the form factor being consistent, as well as the manufacturing design of the board being consistent. That's actually a really big deal for customers when they want to have a consistent system over time. So for a big project, something that is going to be standing up computers over the course of a year or a couple of years or something, if you go with the consumer card, you'll have an endless supply of problems related to product availability, product consistency. There is no roadmap on the consumer side like there is on the professional side. And so we do a lot of consulting with our customers, especially ones with large projects. And a lot of times we'll find that the professional solution is a much better fit for them because of logistics, not just because of the performance or the features that Tim was talking about. There's a lot on the table when you have that conversation.
Okay, great. Thank you.
And I think it's good to say that we want to make our GPUs available to everyone. So if you are doing a research project, if you're spinning up an idea, if you have a great idea out there for a project which is going to help our federal government, it's going to help the military, it's going to help the warfighter, I think it's great that you can go to Best Buy and buy a consumer card and get started. We want that. We want anything that you can develop on that consumer card can then be ported into other platforms, be a professional card that's an add-on into a RAVE system, or it's a system that goes into the cloud itself. But I think you have to always be cognizant, and when you move from that development phase or that research phase of, as you're moving along, how do the people support this project and program for its entire lifetime, which will be 4 or 5 years. And that's really where it becomes important to look at the professional cards, the enterprise cards. The Nvidia can provide proper support to our partners and to the customers.
Okay, thank you. So that kind of brings me to leads into another question. So integrating live and virtual domains in a military environment poses some interesting challenges. Example is augmented reality, trying to do that connectivity at a combat training center for the Army. And so what would you, let's talk about, what would you say are the key areas of the GPU technology that people need to think about, and that computer stack that people need to think about to try to solve that very challenging problem? And I'll throw that to Tim.
Yeah, I think we've touched on some of those things already. Being able to offload the compute from the warfighter, move it into the data center. You now have the advent of 5G networks, and we're doing a lot in that area as well. So I think virtualization, streaming, 5G capabilities. Doug mentioned Cloud XR before. So this is our SDK that allows an application to, as far as it's concerned, it thinks it's talking directly to the HMD connected to the system, when in fact, that HMD is connected to another lightweight device, or it's an all-in-one device at the other end of the network. And we can do a lot of amazing things to hide and eliminate or mitigate for the latency involved in networking. Really very impressive. So head pose movement, motion to photon is very, very quick. And in many ways, it'd be indistinguishable from when you had that headset connected directly to a local computer. So that's what allows for, now a more mobile experience, a more deployable, a more point of need at the image experience, is that streaming capability from the data center.
Okay. I think the biggest challenge for everyone who's trying to do augmented reality, virtual reality even, is latency. And it's the time, every time that you move your head in an HMD, you want the graphics to update extremely quickly to keep up with that head movement. If not, you'll get all of these kind of negative feedback going on in your brain. And I think one of the big things that we've done in this latest generation of GPU hardware is really concentrate on the latency in the system. And you can reduce latency in different ways. We can increase the frame rate. The faster we can update the image, the lower the latency. We launched, or we're in the process of launching, Nvidia Reflex, and there's a Reflex SDK coming out, as well as hardware, to measure the end-to-end latency of an application. And I'm very excited to see how this community actually adopts that technology and how they can integrate it into their systems. Because we'll begin to understand where that latency is occurring in the system. We'll understand where the bottlenecks are and be able to help people tune their applications to run faster. And then there's other latencies in terms of if you're having a mixed reality, you have to get the video and the graphics synced up, and you don't want to have slow feedback there. So Nvidia, many of you are probably aware that we bought Mellanox, a networking company. So we're working with our networking BU to look at the throughput of the system. So how do we get video from a NIC, or how do we get the graphics to the NIC as quickly as possible? And we have a technology in SDK called RiverMax, which allows you to do uncompressed video directly from the graphics card to a networking interface device. And again, we're doing that to reduce the latency in the system.
Yeah, so one of the questions was, so can you talk about current and emerging render and data management technologies useful for the immersive and the cloud 5G operational environment? And I know you were talking a little bit about that, Doug. You might want to, can you talk a little bit more about that? And Rave, can you have any experience in 5G wireless at this point?
So 5G is interesting because, 5G is the next generation of wireless bandwidth. And it's really designed for low latency as well. So it's designed for having a large number of users in a concentrated space, and also having a low latency network as well as your bandwidth for the network. So but it's really the number of users you can have in a space. And it is exciting to us because, the telcos are looking at 5G, and they look at today, we're all using applications that reside in the cloud. Every time you pick up your iPhone, you're running an application and it runs in the cloud. So there's some applications that the cloud is too far away. So we want to have it at the edge of that mobile network. So they're looking to add the applications there. And we're working with a number of telcos just now in terms of getting our hardware certified to be placed at the, effectively the mast points, the antennas for the 5G networks. So we can serve our applications just like it was a cloud server, but locally. And that helps with things like VR streaming, AR streaming, new ideas that we haven't even thought about yet, because we're too old. There's people who are using this technology all of their life will come up with better ideas than we can come up with.
Yeah.
But that's what we're doing. And as we do this in 5G, the devices that go into the RAN at that point of the network need to be secure. So our new Nvidia A40 actually has a security chip on it. So secure boots. So this is going to become something that becomes more and more important to this community as we go into this model of serving out training as a service, is that the hardware behind that, it needs to be hardened. Just like we ruggedize hardware today to go into different environments, we're going to have to ruggedize the software. And partly with that is having like a chip on the GPU itself for that security part.
Yeah. Anybody else? Karl.
So RAVE's position in all of this with respect to 5G is we have partnerships with companies like Nvidia, Intel, the major players. 5G takes the biggest players in the world to become real, and it's happening, which is wonderful. You'll see RAVE putting these A40 cards into systems that belong at the edge to support these larger new style of employments.
Okay.
We won't work directly with 5G technology ourselves. We'll work with the components. We're a system integrator. So just like we have in the past, we'll continue to integrate the latest technologies with the support of NVIDIA.
So one of the concerns of customers is trying to make packaging smaller and smaller, trying to get it to use less power. And you know, that obviously, you get to some trade-offs at that point in time. So Karl, could you talk a little bit about, you know, what those trade-offs are about, you know, a very powerful GPU, but yet now you need a whole lot of power supply and more power than people really have available and such. Can you talk about a little bit about those issues and what customers are facing these days and some solutions that that you're thinking about?
Yeah, for sure. What we're seeing today has been consistent for years, which is the power draw of the CPUs and GPUs is going up generation after generation in a lot of cases. That's not always the case, but if you have to shrink and shrink and shrink your environment, you can get to something like what you've got behind me here, which is a miniaturized render beast. So very, very small, but when we upgraded the GPU to the latest version, we had to make sure that the power supply had enough juice, and of course is now drawing more power from the wall. And the way we address this is we do a lot of testing. Instead of, a lot of customers will say, well, I'm not sure what GPU I need, so give me the biggest one. And I'm ordering 150 systems. And when we look at something like that, it's, well, let's get the meters out, run the application on different sets of hardware and find out what you really need to get the performance level you need. We can reduce power that way. And when we reduce power, we're reducing the size of a GPU, so size, weight, and power all go down. But what we'll come into these days with these massive deployments that are happening with, so many trainers hooked together for larger training experiences is the virtualization and centralizing the GPU compute and sending that out to a smaller, lighter weight client.
And while we're talking about power and efficiency, I think it's worth pointing out that with this new Ampere architecture, we've seen a pretty significant jump in both metrics, more significant than we're used to seeing with any architecture change, even within NVIDIA architecture jumps. In some metrics, we're seeing a 1.9x performance per watt improvement with Ampere. That's incredible. Even something like 15% would have been excellent for a jump between architectures. So to see numbers like that with this new architecture is pretty unprecedented. And then same with the performance as well. If we compare the consumer flagship cards between what was just recently launched and what it replaced, even with real world rendering benchmarks, we're seeing as much as a 40% or more increase. So those gains are tremendous for just a single architecture jump, and that all does a whole lot to address that issue.
Well, that's a good point in terms of Ampere, not only virtualization but also the efficiency of the GPU itself. Maybe NVIDIA, can you talk a little bit about that? What does the future bring? Where is this all going? Can we expect even more GPUs with more processing power, more processing capability, with actually utilizing less power, so you get more processing per watt, if you will, as Matt said?
So
I think, yeah, go ahead, Doug, sorry.
I've thrown out the challenge to NVIDIA here.
So we're, the processing power, some of that increase becomes because we keep shrinking the size of the chip. So the smaller that we can make a chip, the less power it will consume. And equally, the more transistors that we can put onto that chip. We're basically at, I think it's 8 nanometer now. Technology is the Ampere. There's some room to go even lower than that. But we're at the edge of that performance today. But yes, you're going to continue to see improvements over the years in terms of performance per watt.
Good. And so add virtualization to that, and that's how I guess you're all suggesting that's how you get efficiency out of the GPU and the entire computer stack.
So this is, we're always going to have users who want like the full power of that GPU,
Sure.
who want to create the holodeck example of, you can't tell the difference between real life and virtual reality. I mean, we're some way away from that, but the technologies are coming along that are enabling us to see that future. There is if anyone wants to go into YouTube and look for Digital Doug from Digital Domain, no relation to me, they'll see like the quality that you can get from film studios in terms of visual avatars. And it's very difficult to tell the difference between real and not real. But a lot of applications don't need that graphics power. And if they don't need all of that graphics power, we can then use it more efficiently and divide it up amongst different users. There's other efficiencies that are coming along as well, and just how we begin to think about the software that we create. If you can imagine an application that has a physics engine in it and is a training scenario for 100 users, that physics simulation today has to run on each individual PC. And it's just doing the same calculations on each single one. If we start to put things into the server, into the cloud, you can see that that process being split off and run on its own machine or virtual machine, just doing the physics calculations for my world. And I'm not repeating it 100 times. So I've just taken all that computation and put it into a single node in the server. And then you do fast updates. And because it's in the server room, we can have very fast networks between these virtual nodes. So it looks like it's all running in real time, and it looks like it's running on a single application at the end of the day. And we're kind of developing this at NVIDIA. We have a program, a platform called Omniverse. And today it's kind of looking at the manufacturing space. It's looking at the media and entertainment space. It's looking at kind of design works or design applications. But it allows users to use different applications and basically join them together. It has a shared file format called USD, which is an open format. And you can do these very fast updates. So you can get kind of live motion on one hand into a 3D model. So you could do live tracking, or you could track somebody's face and be able to see them talk as an avatar. So, there's lots of exciting things come with new technology, and just exciting ways of thinking of how we build the software for that technology. And that's probably going to be one of the changes.
Yeah, thank you. So, which brings me to one of the questions from the audience. Interesting. The question is, do you have any metrics collected on performance versus the complexity of the applications being run? Send that to Karl. Can you talk about that a little bit? I'll let Karl hit that first, then Tim will come to you.
Yeah, there are a couple different answers. Speaking from the RAVE point of view, we do a lot of benchmarking. We do a lot of, we use utilities to measure different things, and we do a lot of hands-on benchmarking with the actual customer application. But you can get a lot more sophisticated than that if you get NVIDIA, a system architect at NVIDIA involved, for example, or use some of their tools that Tim can explain.
Yeah, I mean, I think it really depends on if you're looking to optimize an application for a platform, then there are profiling capabilities that we provide. There's a tool called Insight that can tell you exactly where the bottlenecks are in your app and allow you to target, changes in that application to get the most use out of your hardware. If you're talking about applications that are already developed and you're just looking to find out, how much computing resources does this application utilize, then we have something like the GPU profiler, which can track, CPU, RAM, GPU utilization, how hard the encoder on that GPU is working. And that'll help you to balance maybe for sizing, if you're going to use a VM, how much can I divide that GPU up will depend on the results that come out of an application like that. So yeah, it depends on what you're talking about. There's no one size fits all answer for how you do that profiling and that sizing. It really depends on the unique conditions in the application that you're working with.
And that profiler tool, that's an unofficial tool from NVIDIA. It was actually developed by one of our colleagues, another SA, who thought it'd be good that, how can we collect metrics on an application to see how much resource it's actually using. So you can download that for free. You run your application and you log the results over a period of time, and it will give you a good idea of, how much resource is actually being utilized on your system.
Okay, thank you. So I have a question. So there is a new acquisition approach being used by the Army's synthetic training environment. I know I've had some questions on how does the GPU support that, how do advancements in the GPU support the synthetic training environment. And so the way they're using it, it's called software acquisition pathway. Some of you may be familiar with it, but oversimplifying it a bit, the essence is deploying a minimum viable capability product, followed by regular software releases, perhaps annual software releases. And the software releases kind of add complexity. So they had features, they had improved performance, they enhanced, they had connectivity, they had live simulation and such. So my question is then, so what are the implications of that strategy on the selection of the hardware stack and the GPU? Would you care to comment on that one? Karl, you start.
I think that
so they want you to build in, I guess you have to build in some rope and some room into the hardware, unless it seems, maybe I'm wrong here.
Yeah. One of the things, there are quite a number of things that conversation entails. Going with larger hardware capability, a larger GPU than you need for your application today is a wise thing if you're going to try and enhance your functionality with software updates. And so oversizing a system, over provisioning a VM, that kind of thing, to me makes sense. But another aspect to it is what we were talking about with consumer versus professional cards, where if your GPU in every few months you ship a system or cores looks different because you can't have the previous GPU available, then you have to do your sizing over again. Perhaps maybe you have some different performance experience, maybe you have some integration problems, and so in that particular conversation, we recommend a professional card.
Interesting. Tim, you look like you want to.
Yeah, I think this is another area where virtualization is a big win, because it allows you to kind of flex those resources in the future depending on the needs. If if the application gets bigger, it needs more GPU resources, then you provision more. And so I think that's one of the huge advantages of going this route. You don't have to have that individual node fully baked in an exact configuration from here into the future. You have a flexible architecture that can grow with your needs. So I think it's a huge advantage of virtualization. As Doug mentioned before, you can even expand it. Each VM can use multiple GPUs if that becomes necessary. But from a system architecture perspective, from a hardware perspective, you can have that same platform be utilized in these multiple different ways, different configurations. So it's a very powerful kind of Swiss Army knife-like approach.
Yeah. So are there any kind of non-traditional applications of GPUs that you're not hearing about that maybe people need to consider?
I think one of the big things that people actually use every day, but probably don't realize it's been run on the GPU, is natural language processing. We talk about augmented reality, and immediately our minds all spring to the visual component. But you can also have an augmented reality by having an intelligent kind of digital assistant. You know, if you're in a virtual synthetic environment, you want a realistic avatar that you could have a conversation with, rather than just repeats the same commands over and over again. So GPUs, we have a full toolkit for our GPUs to do natural language processing, to help people to do this. And you know, this is what people are doing in the cloud today. So every time you ask Siri or Alexa or any of those types of tools, the chances are that the processing for that is being done in the cloud on NVIDIA GPUs.
Great. Okay. So here's a question. Many of, I guess this is the Navy's models are not parallelized, and there's a changing software architecture and is a major overhaul. Do you have any recommendations on transition?
So without having some context about what the models or the application is hard to say. You can now kind of parallelize an application to do compute very straightforwardly by, NVIDIA has native C++ extensions. We also have a OpenACC, which allows you to put in directives into your code, and OpenACC goes and finds where it could be parallelized by finding all the loops and converts that code to a parallel algorithm. So, you know, there's things like that. There's also, you know, there's companies out there who are doing this work as consultants, and on how you can help parallelize your code and modernize it. So, you know, there's options for people to start developing or updating their software.
Okay, so I had a question. So the military market continues to want, you know, kind of smaller form factors for portability reasons, kind of low power requirements. And I said in the beginning that what they have to do, what the military has to do, is leverage commercial technology. So where is the commercial world going, you know, in the use of power and the use of size that might, in the near term or the near future, continue to help the military satisfy those particular needs that they have? Start with NVIDIA. Tim?
Yeah, so if you look at the trends in data centers and high performance computing, we're seeing just massive improvements in power efficiency by leveraging GPU technology. You know, if you look at the top 500, especially on the green side, the most power efficient supercomputers are all GPU based, and that's a function of being able to consolidate all those GPUs into a single system and eliminate a lot of redundant, power supplies and hardware and the heat that's generated, all of that. So I think that's the big trend there is that consolidated infrastructure that you see in performance computing and in cloud data centers. That's where it's moving.
Okay, great.
I would add to that, you know, everyone's thin and light laptops. Everyone wants more processing power. So our mobile processors are about as powerful, slightly less powerful than our add-in cards. So you can buy a laptop today that has the power of our RTX 5000 card, which is a very powerful GPU. We also offer a program for embedded products as well, of taking those mobile processors and putting them in custom form factors. So, you know, we try and service everybody's needs in this market.
Sure.
Yeah. You just said it, Doug. In our world, you have a couple of choices. You can go with discrete equipment, like has been miniaturized in the picture behind me. You can go virtual, like in the photo behind Matt. But we've also done some work with the mobile processors that Doug's talking about on our render beast line. We have a mini beast where we took a computer with this configuration and put it into about a third of the volume by moving the GPU to a mobile platform and then working out some fairly unique cooling in a custom chassis.
Okay, great.
So the miniaturization of the processors is really, really helpful when you need to have a whole computer all to yourself and you can't attach to the cloud.
Okay. Hey, everyone, thank you very much. Really appreciate great dialogue, I think. To those listening in, if your questions were not answered, or if you have follow-up questions again, or you want to talk privately, please go to the RAVE virtual exhibit, and they'll steer you to either RAVE, both RAVE and Nvidia, whoever you're looking for. As an alternative, again, you can go directly to RAVE. They'll get you to the right person. So in conclusion, I want to thank the panelists. Appreciate it, gentlemen, and thank you all for tuning in. I hope the panel was both informative and stimulates your thoughts about your particular application and how to get the most from the GPU. So thank you very much. Have a great day.